10.6, we are doing volume. We talked about 3D shapes a couple lessons ago. 3D shapes aren't called shapes, right? They're called solids. And now we're going to deal with the volume of some of these solids. We've been talking about surface area around some of these 3D shapes, but guess what? Surface area is still two-dimensional. Surface area is still flat, right? If you put it into the net, it's still a flat, two-dimensional, flat thing. But volume is three-dimensional. You not only have length and width, you have depth. Ooh. All right, so now today we're doing, see if you can see up here, volumes of prisms and cylinders. Now that might sound kind of lame, but guess what? Pretty much like every shampoo or bottle or little, I got like a little spray thing of, you know, Pam at home for the frying pans, or water bottles such as this one here. There are so many cylinders, and if you're a company that, you know, let's say you create some sort of magic potion for helping feet not to stink, and you want to sell this, well, in your packaging, you've got to figure out how much of this potion, how much volume this cylinder can contain. So cylinders are all over, right? Now the other thing that's kind of nifty about this, which they don't show here, but I'll go back to this. The other thing that's kind of cool about this is that why do we need to know the volume of a prism? It's like, I never see prisms, okay? Like, we never use the word prism in life, right? But the truth is, every box, get this, every box that you get shipped to your home, or that you store this or that in, every box, and there's a lot of boxes on this planet, every box is a prism. Because a box is a rectangular prism. It has a rectangular base. Because what is a prism? It's a solid that has a polygon base. Could be a triangle, could be a hexagon, or it could be a rectangle like a box. And it has rectangular sides. So every box is a rectangular prism. And is it important ever to be able to know the volume of a box? Yeah. A lot of times it is. So let's just get in with these formulas, and we'll get out, and you'll be smarter for it. All right? Let's check this out. In the real world, residents of a community can, what is that? Choose between two recycling bins. Oh, residents of a community can choose between two recycling bins. Which recycling bins hold more? Okay, so the volume, obviously you got to figure out the volume to see which one holds more. So let's see the volume of a prism. It is the area of the base, which could be a triangle, could be a rectangle, could be a nine-gon, right? Could be something. Area of the base times the height. Seriously? That's it. Area of the base, and then multiply by the height. Volume. Now, it's pretty simple, except volume is not measured in square units. It's not inches squared. This is a whole different dimension. It's cubic inches. So you'll see that written like this. Inches cubed with a little 3 up there, or cubic inches. So 12 times 8 times 2, 192. Or in this case, 3 times 4 divided by 2, because that's the area of this triangle. 3 times 4 times 1/2, or divided by 2, times 10. Now in this one, excuse me, the triangle is still the base, right? Because this is a rectangular, or I mean a triangular prism. The faces of a prism are rectangles, blue here. So don't try to think that the rectangle down underneath that we can't see is the base, just because it's sitting on the bottom. It's not. Okay, so know what your base is and what your height is. All right, so let's go to volume of a cylinder. Do you think it's going to be much different? No, it's not. It's the same thing. Area of the base times the height. The volume is pretty easy of these simple shapes, right? 8th graders, we get to talk with the 8th graders about the volume of a sphere. That's kind of an interesting formula. But these are simple. So, volume equals base times height. Now, the area of the base, right? Area of a circle, you'll remember, area of a circle is pi r squared. Make sure you do the r squared first. Well, one example of that. Got a cylinder sitting on its side here. And once again, you may not think you see cylinders much, but you do, right? So let's see, 6 is the, now hold on a second. Is 6 the radius or is 6 the diameter? 9 is the height, but is 6 the radius? The radius is 1/2 the diameter. Okay, so 6 is pointing to the middle of this line, meaning that it is the whole line here. So the radius is actually 3. Watch out. They try to make you think. They don't try to trick you, but they try to make you think, right? Pi r squared times the height. Pi times 3 squared, which is 9, times the height, which is 9. 81 times pi, and that's what you get. Measured in cubic centimeters. Don't forget your units. Alrighty. So, right here, comparing capacities. Which one of these recycle bins will hold more? Well, you could figure out the volume for that, figure out the volume for that. Which one do you think it is? Did you look already? Looks like the cylinder holds more. Cool. Let's take a quick look at your assignment, see if there's anything that is going to be exceedingly difficult. Here's an interesting one. Erasers. Find the volume of each eraser in cubic millimeters to the nearest tenth. How many pencil top erasers would you go through in the time it takes you to go through the large eraser? Oh, interesting. So, should you buy a large eraser? I don't know. Are you going to actually sit down and figure out all the calculations of this? No, probably not. But what if you were in the eraser selling business? You know, who knows where life is going to, where you're going to end up. Some of you probably have huge dreams of being an eraser seller, right? And you could say, hey, you buy my eraser, and you are basically, you've got like 20 pencil top erasers right here in one. Anyway, how could you find the volume of this guy? Find the volume of each. Is this a prism or a cylinder? Think about that for a moment. This is actually it's a parallelogram, right? And then it's got rectangular sides. So if you could find the area of this parallelogram and then multiply by the height of these rectangular sides, then you could find the volume of that. And you can find the volume of this cylinder with our normal cylinder, and then see how many of these you'd have to equal that. Right? So, and I always like looking at the challenge problem. What if you had to find the volume of this? You'd have to break that down, right? I'd maybe draw an imaginary line here, work with this triangular prism of this ramp, work with the rectangular prism of this full base here, and then the rectangular prism of that as well. Alright, 9 minutes. That was that. Have a good one, and we'll see you next time.